Free Agents. By Kevin J. Mitchell. How evolution gave us free will. Find out what you do and don't have free will over. What makes us different from rocks, plants, and other animals? Where does our ability to set goals and consciously shape our character come from? And does true free will really exist if physics governs the trajectories of particles that make up our brains? In this fascinating book, you'll embark on a knowledge-rich tour that provides serious food for thought regarding autonomy. You'll contemplate what factors ultimately influence your own beliefs, priorities, decisions, and ability to change over time. And you'll explore a host of philosophical puzzles and scientific insights on your way to better understanding human volition and agency. First key idea: determinism versus free will. If you've ever played a video game, you're probably familiar with the standard choose your adventure layout. Your character walks into a bar and encounters a surly bartender, a non-player character or NPC, who engages in some pre-programmed conversation with you. Then you're given a choice. Do you want to sit down and hear the whole story, or do you want to walk away? The actions of the bartender are determined by your choice. In short, you have free will, but he doesn't. He's going to behave according to the programming paths dictated by your selection. The problem with free will is similar to this scenario, except that the question is, are humans NPCs, or are we agents of our own destinies? According to physicist Brian Greene, free will might all be a grand illusion. It's really just the sensation of making a choice. Though the sensation is real, the choice itself is governed by the laws of physics, not by our own agency. This grand illusion has a name: determinism. Determinism can be described in many ways, whether it's the rigid physical laws governing particles and energy, the cascading of events like falling dominoes, or the intricate dance of genes and biology. But they all suggest that the future is already written, like a puppeteer pulling the strings of our existence. Before we dive too deep into determinism, let's acknowledge the complexity of the concept it addresses. Defining free will is akin to catching smoke. It slips through our fingers. Does it hinge on the ability to choose differently under identical circumstances? Or is it more about the conscious intentionality guiding our actions? It's a puzzle, and no one seems to have the final piece. Another layer to this intricate debate lies in the motivations behind it. Many seek to validate their religion or morality using free will as a cornerstone. As we venture further into the exploration of determinism versus free will, let's be mindful of these diverse motivations and the potential biases they introduce into the conversation. Here we go. Second key idea: what is life? In the classic Monty Python Dead Parrot sketch, John Cleese insists to a shopkeeper that a clearly lifeless parrot is dead, while the shopkeeper vehemently claims it's still alive. It's a hilarious scene that hints at a more profound point: the boundary between life and non-life isn't always crystal clear. Physicists define life as an ongoing process of maintaining order and activity, pushing back against the forces of entropy, which, broadly speaking, means disorder. Just think about rocks. Rocks can endure almost indefinitely in an inert state because they don't react with the environment. But living organisms must constantly work to uphold their highly organized physical structures amid the chaos and decay surrounding them. This continuous battle against increasing disorder demands a steady influx of energy, managed through the metabolic process of breaking down nutrients. Where did the early precursors of life find their energy, even before processes like photosynthesis existed? Turns out, groups of molecules near geothermal vents on the ocean floor tapped into a continuous energy source provided by hydrogen ion gradients, which are ions that can move across a membrane. Protective membranes, crafted from fatty molecules, eventually formed around these reactions, creating distinct boundaries between protolife and non-life. Within these protective bubbles, complex molecules like RNA and DNA eventually emerged. These biomolecules played a crucial role in early life, dictating responses to environmental changes. Protocells capable of replication began dividing, passing beneficial genetic mutations to subsequent generations. The combination of random mutations and selective reproduction propelled evolution from basic cells to complex multicellular life. In a living thing, every component fundamentally works toward preserving the entire organism. This gives rise to what look like goals, values, and interests, a sort of self-directing reactions. Let's find out what evolution brought us next. Third key idea: sensing, analyzing, and deciding. Organisms aren't merely spectators in their environments, they're dynamic players, sometimes outpacing the slow march of evolutionary adaptation. Take a bacterial population boom, for example. It can deplete available nutrients faster than evolutionary forces can adapt. But how did organisms evolve into such active agents, working in their own interests to overcome environmental obstacles? Even in the realm of simple unicellular organisms, there's a hint of agency. Consider yeast adjusting its metabolism based on environmental oxygen levels. This responsiveness points to a basic form of agency. Sensing the environment is a crucial part of this responsiveness, and over time, organisms evolved various sensors for light, vibration, chemical signatures, and more. All these sensory tools and behavioral flexibility were in service of the fundamental imperative, survival. But survival isn't just about sensing, it's about movement too. Organisms had to develop the ability to seek resources, find mates, and escape threats. What began as undirected movements evolved into taxis behaviors, oriented, purposeful responses to stimuli. The question arises, does directed motion imply conscious choice, or is it merely a result of mechanistic reactions? Could awareness or intention have evolved from the simple sensing of and response to information? Scientifically speaking, responses like taxis behaviors are programmed by genes to aid survival, and they don't need higher cognition. But what if we consider something like information exchange? Even bacteria share details about food or toxin presence. This could be seen as the beginnings of rudimentary agency, an ability to select behaviors based on meaningful information rather than fixed cues. And the abilities of organisms didn't stop there. As they incrementally acquired tools to sense, process, and utilize information about their dynamic surroundings, they laid the foundation for awareness and intentionality. Eventually, fully conscious beings emerged, with their own priorities. This, in essence, is the journey toward what we might call free will, an agency that goes beyond mere survival instincts. Fourth key idea: the evolution of cognition. In the evolutionary saga, the first neurons likely emerged in eukaryotic organisms. Their job was to coordinate sensation, motion, and interactions with the environment across groups of cells. Specialized neurons entered the scene, transmitting signals that allowed multicellular life to function as a unified whole. Picture it like this: light-sensing cells sending data to central processing networks, which then send commands to muscle control cells. Now, while quick reflexes to threats are essential for survival, there's a twist: enter mediating neurons. These neurons slow down reactions, allowing for the integration of more perceptual data, and enabling more considered actions. Instead of reacting to each sensory input in isolation, organisms take a step back and examine the whole scenario. Dedicated neurons also evolved to represent and regulate internal states, such as energy levels. When resources are low, hunger signals kick in. Emotions build on this foundation, using shared circuit elements to convey value appraisals, as in good or bad, pain or pleasure. These appraisals play a role in cost-benefit calculations for decision-making. Brains like ours can also retain neural connection patterns. In this way, they are catalogers of experience. This cataloging sharpens instincts and allows us to learn new adaptive behaviors without the need for genetic changes. Consider associative memory, an efficient system linking stimuli to appropriate responses. If a specific tree consistently bears fruit after rainfall, for example, our brain remembers this correlation, allowing for strategic decisions in the future. It becomes possible to override rigid innate programming. All of these cognitive developments enabled organisms to respond not just to immediate conditions but also to draw on past learning and project outcomes into the future. This set the stage for actions driven by internal reasons rather than solely by external factors. In essence, we leap from reactive agency to deliberate volition, which sounds a lot more like free will. Fifth key idea: the sense of self and choice. Basic agency, or doing stuff based on what you see and feel, is all about perceiving the world and responding accordingly. But for more sophisticated beings like us, there's an extra secret sauce, a sense of self across time and space. As evolution did its thing, we upgraded our visual systems with camera-style eyes and added auditory structures like eardrums to the mix. This gave us a richer scope of what was happening around us. But just having raw data wasn't enough. We needed to actively interpret it to make sense of the world. Take vision, for example. It's not just about seeing light patterns, it's about translating those patterns into shapes, objects, and motion. And where does all this magic happen? In our neocortex, the brain's problem-solving headquarters. Now, our sensory systems can be a bit tricky. Ever seen an optical illusion? They prove that what we finally perceive depends as much on our brain's processing as it does on actual stimuli. Our inner knowledge and assumptions play a big role in how we interpret the world. The same goes for how we move around and interact with our surroundings. The more we actively explore, the better we understand space and the cause and effect relationships between our actions and what happens next. Our brains are like the ultimate mapmakers, connecting the dots between what we see, what we do, and what we feel. Over time, our brain systems got even smarter, coordinating new and more complex options for behavior. They developed the ability to look into the future, simulating potential outcomes and helping us avoid risks. They were also able to align simulated scenarios and the resulting feelings with a set of prior experiences, preferences, and memories to weigh up choices. Acting based on this integrated sense of the past, present, and imagined future is what gives us intentional decision-making powers. It's not just about reacting, it's about having a say in our actions, a taste of what we call free will. Sixth key idea: random decision-making. Quantum physics throws a curveball at physical predeterminism, the idea that there's only one timeline. It introduces intrinsic uncertainties, challenging the notion of a strictly predefined future. You're likely aware of Schrödinger's cat. The moral of that story is that many or all states exist until the point at which they are measured, or the point of decision-making. Then they collapse into a single reality. This means that if we were to look at a picture of the future, it wouldn't be a line or a series of optional lines, but rather a blurred image that gets blurrier the further out you look. Essentially, the only time that a future is knowable or clear is after a decision has been made. In the parable of Buridan's ass, a donkey is standing between two piles of hay. He's at an equal distance between both and neither hay pile is better or worse than the other. In the absence of a clearly better option, the donkey makes no choice and starves to death. The absurdity of this tale leads us to think about how we are capable of making random decisions even in the absence of clear pros and cons, simply by choosing to decide. In several studies, electroencephalograms, which measure electrical activity in the brain, reveal that the moment of decision happens just before we're consciously aware of it. Welcome to the two-stage model of action selection. In this model, an initial automated phase, driven by learning and instincts, paves the way for a secondary rational phase, where our highly developed brains are capable of overriding our instincts, making good or bad decisions based on things other than survival, and effectively shaping the world around us by choice rather than evolutionary imperative. In this dance of determinism and indeterminacy, individuals harness randomness for timely, arbitrary decisions. Decisions which strongly point toward some form of free will. Seventh key idea: your character and your choices. Even if we accept that we have some measure of conscious free will, that doesn't mean we control everything. Nature and nurture constrain many aspects of our wants and personality. Genetics and neurobiology shape our innate dispositions while our upbringing molds our habits and beliefs. So do we have a choice in who we are as individuals? To answer that, we need to understand personality and character. Personality refers to emotional patterns, social style, motivations and other facets that persist across external and internal contexts. Character means virtues, principles, and priorities that guide our behavior. Both have biological and cultural roots. But who we are, our identity, goes even further than this. It also depends on the stories we construct about ourselves when we integrate our experiences into personal narratives. Now, given that we curate our experiences, relationships, and education deliberately to reinforce helpful narratives, we can say that we do influence our own personality and character. Of course, personality comes before any influence we have over it. That's because personality starts being formed before we are even capable of consciousness. As we become conscious and mature, we are able to further shape our already existing personalities and characters through deliberate choices. What we get is a trajectory of free will that starts out heavily indeterminate and shifts to largely determinate as we mature. Whenever we overrule emotions, habits, biases, and randomness with our higher-order thinking, simulation, and logical deliberation, we exercise our free will. We consciously examine the roots of feelings and may choose to alter our reactions by reframing the subconscious narratives that guide us. The truth is, we as organisms are capable of creating change in the world, of coordinating activities, and even of shaping ourselves. And this is simply incompatible with the belief that the future is predetermined. In other words, given the capabilities we have, determinism must be false. We have free will, and we have evolved it as the next phase in our evolution. What we do with it as a species is yet to be determined. In summary, free will depends on an evolutionary chain from metabolism and agency up to consciousness and selfhood. While some argue that our choices are merely results of sensory inputs mechanically driving our behaviors, the story is more complex. As we evolved more and more sophisticated methods of sensing, processing, choosing, reflecting, and acting in adaptive goal-directed ways, we developed newer, higher-order faculties like simulation and self-awareness, which is difficult to account for without a notion of free will. Human thought and behavior bridle randomness to sculpt character and direct actions from an inner sense of identity. Determinism alone cannot fully predict or explain this.